Hello everyone. So in this video, we'll learn about the one-pass macro processor algorithm. Okay. So before we start the algorithm, let's look at the data structures required for this algorithm. So there are mainly three data structures that you will need. Just like how you have seen sim tab for assembler, for macro, you need similar data structures like def tab, name tab, and arg tab. Def tab is a definition table. It will contain the macro prototype and the macro body. Name tab contains the macro names. How much ever macros you have, name tab will contain its names. So this name tab is mainly used as an index to your definition table. And for each macro instruction defined, name tab contains pointers to the beginning and end of the definition in definition table. Okay, so name tab mainly contains the macro name and pointers to the beginning and end of the definition in definition table. And finally, arg tab, which is your argument table, it is used during the expansion of macro invocation. So associated with every macro, you have a prototype and a body, and a statement will be there which invokes the macro. So argument table is used during the invocation time. When a macro is invoked, the arguments are stored in argument table. And when the macro is expanded, the arguments are substituted in the macro body, which is in fact taken from argument table. Okay, so these are the three data structures. Let us visualize this with this example. So you have name tab, arg tab, and definition tab. So here you can see definition table stores the prototype. Okay, so here the macro is rdbuff. Rdbuff is a macro, name of the buffer, sorry, name of the macro, and this is the macro body. So your definition table stores the prototype. See, this is the prototype. Ampersand, there are three parameters in fact here. One parameter got, when I took the, when I took the copy of this, maybe it got striked off. Actually, you have one more parameter coming in this macro definition. So that is why here you have this REC length also. Okay, that is a macro prototype. And this is a macro body starting from clear X till mend, macro end. So this is a macro body. Definition table stores for every macro that you have, it will store the prototype and body. And this is name tab or name table. It will store the name of all macros and two pointers. The two pointers, the first one will point to the beginning of macro and second one will point to the end. So it's like an index to definition table. And finally, your argument table will store the arguments associated with that macro. So for this macro, you have three arguments, right? 1, 2, and 3. So this is taken from your macro invocation. I do not have that macro invocation statement in this slide, but you would have seen it before. In that macro invocation statement, when this macro is invoked, rdbuff is invoked, you'll be having f1 buffer and length. I'll show you later in the coming slides. So at that point, this table is created with the positional parameter values and the argument length, argument names. Okay, so these are the three data structures. Now let us look at the algorithm. So this diagram shows the various procedures used in order to construct a macro with this one-pass algorithm, one-pass macro processor algorithm. So here you can see in the main program, there are mainly two iterations of two procedures. Okay, there are mainly iterations of two procedures, get line and process line. So your whole algorithm contains 5 procedures totally. Main program, get line, process line, expand, and define. These are the 5 procedures used. In the main program, you keep on calling get line and process line. So what happens in get line is you will read get line from the name itself, you are reading a line. So the line will be read either from the input file or from the definition table. Okay, so that is what happens in get line. Depending upon some condition, you will either read the line from the input file or from the definition table. And in process line, whatever line you have read now, depending upon if it's a macro definition, then you will call the procedure define. Or if it's a macro expansion, you will call the procedure expand. So what happens in define is, in the procedure define only, you are creating the definition table and name table. And in expansion, you create the argument table. And each macro invocation statement is expanded. Then after expansion, you have again lines coming, right? So each line you will read, and in effect, you call get line and process line for those macro invocation statements also. So again, you will get in get line, you will read the date, you will read that line, and in process line, you will process it. Process means either you will define or expand. So this is an overall idea, everything in a single nutshell. Let us look at each of these procedures and try to understand what exactly happens in this algorithm. So the first, okay, I'll show you each each procedure one by one. So this is a main program. In this main program, initially you have a variable expanding. So remember that you only have one variable expanding, which is set to false. So keep this in mind, okay? This is initially set to false. We'll need it later when you have the procedure expand coming. Now, so this is our program, your actual program. So I have written just a macro definition here, and the program starts with a copy statement followed by macro definition. So you have to read each line one by one, right? Therefore, while opcode is not equal to end. So you have to read till your last statement from this assembly language. So while opcode is not end, what do you have to do? You get line and process line. So you remember in our previous diagram, I showed you in the main program, it's mainly the iteration of get line and process line. So you have this get line and process line procedures being called for each line. So for each line, you first call the procedure get line, and next we'll see what happens in get line. And after that, next process line is called. So the first statement is copy start 0. So for this statement, get line procedure is called, and you will see what happens in get line. And after that, process line statement is called. We'll see what happens in process line also. So begin, end, right? So end, while. That means again, the next statement will be taken, and the next statement, opcode is not end. So again, for this statement, get line will be called and process line will be called. So this keeps on happening for the entire statements in your main source program. So remember, initially we have set expanding to false. So let us see what happens. The first line is get line, copy start 0, right? So let us look at what happens in get line. This is the procedure get line. Now begin. If expanding. So what did we set the variable expanding to? We have set it to false, right? So this won't be executed because this will turn out to be false. Therefore, you have your this loop is not getting executed as of now, since expanding is false. So you'll directly go to this statement. And what does this statement say? Read the next line from the input file. So read that line from the input file. So the line from the input file is, this is the line. So read this line. Okay. So read this line. That's what it says. And that is the end of get line procedure. Now what to be done next? I have read the line from the input file. Next, you have to call process line. So let us see what happens in process line. So why I have this definition table here is later we'll need it when you have expanding coming. So for the time being, since that is not our concern, I'm skipping this part. Now let us see, we have read this line. Let's see what happens in process line. So this is process line. So in process line, it says first search name tab for your opcode. So again, we have not like processed anything in your name tab, right? We have not done anything in your name tab. So if found, in this case, it is not found. So this will not happen for the time being. Then else if opcode is macro. No, our opcode is start. So this statement is also not used as of now. It will go to the else statement, write the source line to the expanded file. So what is our ultimate aim? We are in effect trying to convert our assembly language statement and expand the macros to get your actual assembly language before you feed it to your assembler. That is the role of macro processor, right? You read the input assembly language file, and if there are any macros, you have to expand it. So that's what we are trying to do. If there is no macros, write that line directly to your expanded file. So I think I have that, yeah, here, see, this is the first statement, copy start 0. So this is our expanded file. So since this doesn't fall under any of the category which we saw, this is directly returned to this expanded file. This is the expanded file, okay? It's directly returned to the expanded file. So let me make a note of it. So this is your expanded file. Okay. Now let's, so we have read the first line and we have read it and we have processed it. Now this keeps repeating. Let us take the next line. So the next statement is rdbuff. So this is the next statement. It is first you have to get it. Now again, expanding is false. So nothing happens here. Read that line. So read rdbuff and you have to process it. So what happens in process line? So search name tab for opcode. Again, we have not constructed anything for name tab. So since this is false, it goes to the next statement. Check if the opcode is macro. Yes, the opcode is indeed macro. So this is the part where you are going to define the macro. You are going to create the definition table. So that's why else if opcode is macro, then call the procedure define. And this else will not work because already this condition has become true. So you're calling define. So from this statement in process line, you are jumping to the procedure define. So I hope you are able to follow. Let us look at the procedure define. In define, what do we do? We create the definition table and we create the name table. So let us see what happens. So we have taken the statement. What is the statement? This is a statement, rdbuff macro, and you have 3 parameters. Okay, just keep in mind the third one got erased. You actually have 3 parameters. So the first statement that happens in define is enter the macro name into name tab. So the name of the macro is rdbuff. Enter that into name tab. The next statement is enter the macro prototype into definition tab. So this is a prototype, right? rdbuff followed by the 3 parameters. So after doing that, set the value of level to 1. Why we need a level is when you have nested macros coming. Sometimes there is a case, I'll show you a nested macro file. See, so this is a like nested for loop, nested loops, those concepts you're familiar, right? Where you have a macro inside a macro. So this is a outer macro you have, within which you indeed have an inside macro. And again, you have another macro nested, and this is the end of the final outside macro. So in order to handle nested macros, you have this variable level defined. So in our case, we have only one macro, right? So let us define level as 1. Now, while level is greater than 0, we only have one macro. So level is indeed greater than 0. So what are you doing? As told before, define calls getLine. So getLine will just read the line, right? What does the procedure getLine do? It will just read the line. Now again, expanding is not false, so it will read the line, right? So it will read the line. Now this is not a comment. Of course, it's not a comment. You have to define the definition table. The statement is, this is a definition table. So how the definition table is constructed is, substitute positional notation for parameters. That is, in the suppose if it's a statement, here you have parameter in device will come here. Okay, so if that statement contains if the statement which you are reading contains arguments, then in that case you have to substitute positional notation for parameters. So here it is in device. At that point you have to substitute with 1 because it's the first argument. At buffer address, wherever you have buffer address, let's see, where do we have buffer address? See, so at in device you have to substitute, wherever you get in device you have to substitute 1. Why? Because it's the first argument, and here also you will get a 1, and wherever you get a buffer address you will substitute it with 2, and wherever you have receive length you will substitute it with 3. So that's how see, here you can see 1 we have here, 1 we have here, 2 we have here, and 3 we have here, and enter that line into definition table. But here it is not a positional parameter statement, it's a normal statement only. So enter that line into definition table and check if the opcode is macro. Here is where we are checking for nested macro. If it is a nested macro, then increment the value of level by 1. Else, if the opcode value is mend means the last statement, then decrement the level value by 1. So here in our case, it is neither macro nor mend. So we do not do anything with the level value. You keep reading the lines. So see, end if not comment. So we started with here, if it is a comment, and end while. So where does the while start? While level greater than 0. So level is still 1, right? We did not decrement level yet. So level is still 1. Again, it will get the next line. So the next line, so we have read clear. Next, it will read clear A, it will read clear S, and it will keep reading all these statements. That is why you have a get line coming in this procedure. So you keep reading all the lines and you add those into definition table. If it is a if it contains an argument, substitute it with positional parameter, and all these statements will happen until you reach the last statement, mend. So far the value of level is 1. This is the last statement, mend. So let's see what happens if it's mend. So substitute positional parameter will not happen. Enter line into def tab. So we have entered mend into def tab. Now check if macro opcode is macro. No. Else if opcode is mend. Yes, our opcode is mend. Decrement the value of level by 1. So the value of level is 1. It has become 1 minus 1, 0. Now this while statement will become false because level has become false. And here we have defined the definition table. And what happens finally? Store in name tab the pointers to the beginning and end of definition. So you remember, we only entered the name of the buffer in name tab. You have to add the pointers as well. And that is what happens in define. So this is your define procedure. So where did we call define? Let us see. In process line only we called define. So when did we call define? When we encountered a macro definition statement. So the actual flow is, you get the line, you process the line. Again you get the line, and you process the line, and you keep doing it. So you have entered the whole macro statement into the definition table, and you keep reading it. Now let us see what happens next. So I think I have the program. Yeah, here. So this is the entire program. Okay. So so far we have only, in the expanded file, I have only added the first line so far. Then we were adding everything in the definition table and name table, and it keeps going. And your main program starts here. So this is the first main program, and you have the first statement, first STL return address. So the same steps happen for the every statement in your program. So here it will get the line and it will process the line. So it is not a macro. So that line will be written to the expanded file, right? So since this is not a macro, you have this file, this statement written, and this statement also written. Now comes your macro invocation. Okay, this is a macro invocation statement because you have the name of the macro coming, rdbuff. So when you read the line rdbuff and when you process it, let us see what happens in process line. So now here when you're processing it, now search name tab for opcode. So what is the opcode in this statement now? The opcode in this statement is rdbuff. So here you are checking if the name in the name tab you have macro defined. This happens every time, but so far we have not created name tab. That is why we skipped these statements. But now at this point, when we search name tab, we do have rdbuff present inside name tab. So if it is present means it is already defined. Now you have to expand it. That is why if it is found, then call the procedure expand. Okay, so I'll come again. What are you doing? You are reading each statement from the assembly language program. If it is a normal statement without any macro definition or invocation, you write it to the expanded file. If it's a macro definition, you create the definition table and macro name table. Okay, if it's a macro definition, you create the definition table and name table, and in definition table you add all these statements, which is your macro body, into the definition table, and in the name table you add the name of the macro and the pointers to the definition table. Then the third type of statement which can be present in your program is macro invocation statement. So this is an example of macro invocation statement. So when you process a macro invocation statement, what do you have to do? That is what is given here. So if it's a macro invocation statement, then your name table will contain the name of the macro. So if the name of the macro is found, then call the procedure expand. So far we have seen get line, we have seen process line, we have seen define also we have seen. The only procedure which is left is expand. So what happens in expand is it will take the statements from definition table and it will write it to the expanded file. So in expand, what you are doing is you are creating this expanded statements. This is what you are doing. Okay, so let us see. I think we'll have till the last statement is stx. So you will have till here 190M. This is your expanded file. Let's see how it is done. So in the procedure expand, so you remember I had asked you to keep in mind that expanding, the value of the variable expanding is set to false initially. So in expansion, you are initially setting it to true. Then what do you do? Get the first line of macro definition from def tab. So we have identified that it is a macro rdbuff. So get this line from def tab and set up arguments from macro invocation in argument tab. So in expand, you are creating your argument table. So what is your macro invocation statement? Your macro invocation statement is F1 buffer length. So take these arguments and create your argument table. That is, set up arguments from macro invocation in argument table. F1 buffer length. Then write the macro invocation statement to expanded file as a comment. So the first statement, rdbuff, this line is written to the expanded file as a comment. See, .cloop, this is a comment actually. The first line is written to the expanded file as a comment. And what do? While not end of macro definition. So while not end of macro definition means this is your macro and the end of macro definition is mend. So while not that end, you get the line and you process the line. So get line will read the line and it will process it, right? So the first line, clear X. So it will get the line clear X. Now remember, the value of expanding is true. Now let us see what is written in get line, the part that we skipped initially. So when you get the line, if expanding true. Now here the value of expanding is true, right? So what do you have to do? If the value of expanding is true, then get the next line of macro definition from define tab, get that line, and then substitute arguments from argument tab for positional notation. So get the line of macro definition from your definition table, and if it is a statement which contains positional value, then substitute it with argument table. So initially it does not contain any arguments, right? So it will get that line. You just have to get that line, clear X. It will get that line and then you have to call process line. So what happens in process line? In process line, you write that line to expanded file because both these conditions will not become true. You write that source line to expanded file. So the first statement was clear X. It is written to the expanded file. Now again, you repeat this. You have to keep doing this while the end of macro. So you read the next line, clear X. Now expanding is set to true. So you read this line and you call process line. Process line is simply writing this statement to the expanded file. And you keep doing this until you come across this statement TD equal to X question mark 1. So if you come across a statement which contains positional parameter, substitute it with the parameter contained stored in argument table. So 1 will be replaced with F1. So let us see how this statement is expanded and written to the expanded file, the statement that starts with TD. So here you can see that in the definition table, the value, the statement which was written was equal to X question mark 1. And in the expanded file, this 1 is replaced with F1. This 1 is replaced with F1. Similarly, here also it is replaced with F1. And let us look at STCH question mark 2 we have, and STX we have question mark 3. So STCH question mark 2 should be substituted with buffer, and STX question mark 3 should be substituted with length. Yes, STCH is substituted with buffer and STX is substituted with length. So this is how the macro is expanded. So you keep doing this until the end of macro. Once you encounter the last statement in macro, you again set expanding to false, the initial value. And that is the end of expand statement. So where did we call expand? We called expand in the process line. So after that, again, you keep calling get line and process line. So this is a flow in the algorithm. Okay, you may encounter 3 types of statements, either a normal assembly language statement or a macro definition or a macro invocation. So based on that, how the algorithm works and how the expanded file is created. So here you can see that if you encounter another macro invocation for the same macro debuff, okay, it will be invoked with another set of parameters. Okay, so I think we do have that example. Let me check. Let me check. Okay, I had taken it before. Yeah, see, okay. In here, it's actually showing example for WR buffer. So here for the macro WR buff also, your definition table will be created and your argument table will first contain 5 buffer and length. So why we have positional parameters in fact is every time the macro is invoked, your arguments are changing. So your argument table first it will be stored with 0.5 buffer and length, and next time when it is invoked it will be stored with 0.5 EOF and 3. That is why you have this dynamic option of storing it as positional parameters, which makes it easier when you invoke the macro with different parameters. So I hope this algorithm is clear. You can once again look at this diagram where it shows the entire flow. So you have the main program which calls getLine and processLine one after the other. In getLine, you either read the line from definition table or from the input file. And in processLine, you either define it or you expand it or you output it. That is, if it is a definition, you create the definition table and name table. If it's an expansion macro invocation, you create the argument table. And in fact, in there, it's also you keep reading and you keep processing. And if it's a normal statement, you directly output it in the source file. So I hope the algorithm is clear to you. Thank you so much for watching.